Hello everyone! Today I'm going to talk about Flyby Anomaly. In 1990, NASA's Galileo spacecraft performed the Earth flyby. Flyby is a technique to use Earth's gravity to accelerate the spacecraft and then change the direction of the spacecraft. But after performing this Earth flyby, Galileo's velocity was faster than expected, faster than NASA's calculation. And no one can explain this. It happened again in 1998 for near Shoemaker spacecraft. It was accelerated again by Earth flyby. The same thing happened to ESA's Rosetta spacecraft in 2005. This is not measurement error. This is not calculation error. And these spacecraft all got faster than NASA's scientists expected. And even today, no one can explain why these accelerations happened. Let's look at details.
Mysteries of the universe.
First of all, what is this Earth flyby? So flyby is a technique to use the gravity of larger planet to accelerate the spacecraft. Say, for example, the Earth is orbiting like this and a spacecraft approaches the Earth. Because of the Earth's gravity, spacecraft is pulled and accelerated. In addition, using the Earth's gravity, spacecraft can change the direction to the destination. So that is a very common technique. A lot of spacecrafts use this technique. This is called flyby. And this 1990 Galileo spacecraft used this Earth flyby. So you take advantage of Earth's gravity to accelerate and then head towards the Jupiter. But as I said at the beginning, the velocity of Galileo increased by 4 millimeters per second. This is very tiny amount, but this acceleration is real. NASA is expert, so NASA considers everything, including Earth's gravity, blah blah blah. The velocity of spacecraft can be very accurately measured using Doppler effect. And also, there's another way to measure the velocity. Ranging data also show the acceleration. This ranging data is a technique to measure the velocity of the spacecraft by measuring the time of the signal emitted from the spacecraft reaches the Earth. So it's not a measurement error. And then no one could explain this acceleration. In 1998, Shoemaker near spacecraft, which was heading to an asteroid, also performed the Earth flyby, and it got accelerated 30 millimeters per second. Again, no one can explain this. It happened again in 2005. Rosetta spacecraft of European Space Agency. Rosetta was heading to a comet. This was the first mission to go to a comet. Also performed the Earth flyby and accelerated by 2 millimeters per second. So now problem is becoming serious. Not just Galileo, Near and Rosetta also got accelerated. However, in 2005, Messenger spacecraft did not get accelerated. Acceleration was zero. The velocity the Messenger came out of the flyby was exactly as expected. So what's going on? And then very interestingly, this anomaly only happens for Earth flyby. A lot of spacecraft also use other planets such as Jupiter for flyby, but when they use other planets, this flyby anomaly does not happen. Only Earth has flyby anomaly. What's going on? So scientists came up with various reasons. None of them actually works. For example, they thought about it might be Earth's atmosphere is affecting the spacecraft, but if there's an other atmosphere effect, then it should reduce the speed, not accelerate the speed. So it doesn't make sense. How about the tidal effect? For example, the moon is falling down to the Earth a little by little because of the tidal effect, but the effect to the spacecraft was too small. How about Earth's magnetic field? But spacecraft is not a magnet, so the effect from magnetic field is also very small. How about radiation pressure? In case of Pioneer anomaly, it was radiation pressure from the spacecraft that slowed Pioneer down. Similar thing might happen, but radiation pressure from the Earth is very small, so it cannot explain the acceleration. And then scientists even thought about exotic scenario where Earth's rotation distorts the gravitational field around the Earth tiny bit, and this might affect the spacecraft. The effect was again too small. And then some scientists even thought about there might be a dark matter surrounding the Earth, but effect again it's too small. There may be new physics that we're not aware of. The Flyby Anomaly still remains a mystery. And then here came NASA's John Anderson again. NASA's John Anderson is the person who found Pioneer Anomaly. Please check my video if you are interested in Pioneer Anomaly. That anomaly was solved. He found an empirical relation between the equatorial angle and the strength of the acceleration in a way that the equatorial angle is larger, the acceleration is stronger. And this can explain that it didn't happen to the messenger because equatorial angle for messenger was 0. And then it can perfectly explain the cases for Galileo and also near Shoemaker and also Rosetta. However, when he found this relation, this equatorial angle dependence sounds like a general relativistic effect of transverse Doppler effect. So some people doubted maybe this is some calculation error of this transverse Doppler effect. But this is NASA scientists checking it again and again, and also ESA's scientists were also checking. So it's very unlikely they have error in calculation. According to this Anderson's empirical relation, in 2013, Juno spacecraft, according to its angle, it should be accelerated by 7 mm per second. So people expect 7 mm per second acceleration. However, after Juno performed the Earth flyby, Juno was not accelerated. What's going on? So the Flyby Anomaly still remains an unsolved problem. It's mysterious why this happens only to the Earth. When spacecraft fly by using the other planets, this anomaly doesn't happen. Also, there are some more recent spacecraft that did the Earth flyby, such as Hayabusa, and they haven't released the data yet, so it'll be interesting to check the more recent data. Also in the future, there are two plans, microscope and then STEP spacecraft. These spacecrafts are going to measure the Earth's gravity very precisely to the accuracy of 10 to the minus 15. So if this flyby anomaly is caused by the gravitational field of the Earth, then these spacecraft should be able to reveal that. Let's keep an eye on these spacecraft. The microscope satellite has been already launched and it's already collected the data, so let's look forward to their results. There are a lot of interesting mysteries in the universe. Okay, so today I introduced Flyby Anomaly. If you liked the video, please like it and then please subscribe to my channel. Comments and questions are welcome down below. Okay, see you next time. Bye bye.